So the LeetCode problem we are going to solve now is called power of x to the power n. Now this one is a LeetCode medium problem and also a very well liked problem, but let's understand the problem statement. Basically, we want to implement a power of x to the power of n kind of a function. That's it. This is the whole solution. So in the input, we are given two values x and n, where x defines any integer. So let's say value is given 2 and n would define the power that we need to generate. So let's say given n is equal to 4. So in this case, we'll have to return 2 to the power 4. So this is basically going to mean that 2 multiplied by 2 multiplied by 2 multiplied by 2. So basically this turns out to be 16, and this is what we need to return. Now for different kinds of input, it could be possible that the given value of n could also be negative as well. So if the given value of n is negative, then simply let's say that we are given the value 2 to the power minus 4. So in this case, we can still perform the same operation, but basically we are just doing 1 divided by 2 to the power 4. So this is going to be 1 divided by 16, and I don't know what is the decimal value, but something like 0.06 or something like that. So this is what we need to return. Okay, so let's try to see that what is the most simplest approach to solve this problem. We know that we are given a value of n. It could be positive or negative. Let's consider those scenarios later, but let's say that value of n is given 5 and we are given the value of x. So let's say x is given 2. We can simply run a for loop that while n is greater than 0, basically we would keep on reducing the value of n one by one and multiplying the value of x by whatever the initial value of x we are given. So let's say currently x is equal to 2. During the first iteration, we are going to do 2 multiplied by 2 and the value of n is going to be 4, then 3, then 2, then 1, and so on and so forth. And in the end, we can return this value as 32 as the answer. This solution would work as expected. No issues with this. Now, what is going to be the time complexity? The time complexity is going to be big O of the total number of n that is currently present, and which is a fair enough time complexity. It's not that complicated. But the thing is, we want to make improvements to it, and we want to make this faster and better solution. That for any given value of x, let's say the value of x to the power n that we are trying to calculate, we can also write this value in x square, and then we do n divided by 2, because if we do LHS with RHS, then basically x would become x multiplied by 2 multiplied by n divided by 2. So this is also going to be x to the power n, right? But logically we can come up with this solution. Now notice that by squaring the x with itself, we are reducing the value of n by 2, and we can keep on repeating this operation every single time. So in that case, the solution would run in big of logarithmic of n time complexity. Now let me give you an example on what I mean. Let's take our scenario where given x is equal to 2 and we're given n, the value of n is equal to 4. We know that 2 to the power 4 would become 16, but let's try to use my formula. So in this case, for 2 to the power 4, we can say that 2 square, and then we can also do like on top of it, here the value is 4, so 4 divided by 2, so this is going to be 2 as well. 4 divided by 2. I hope you understood. Now if we do that, we know 2 square is going to be 4 and this value is going to be 2, so basically this is going to be 16, and we can return this as the answer. Now notice in this case, all we had to do is just do this one iteration once. We did not have to do 2 multiplied by 2 multiplied by 2 multiplied by 2. So this is a much better solution, but of course it comes with an additional cost on itself. Now let's try to think that how we can take care of negative scenarios. So if the given value of n is going to be negative value, once again same method can apply, but in this case, if 2 to the power of negative 4, then we need to do 1 divided by 2 to the power 4. So in this case, we will do 1 divided by 2 to the power 2, and then on top of it, it's going to be 2. So once again, the same set of steps are going to be done. The only thing is, for negative value of n, we would change the value of given x to 1 divided by x. So I hope that also makes sense. Now there is another scenario that we did not consider, and that is that so far we consider this value of n to be an even value. So that's why doing like this operation of n divided by 2 was easy, like this operation. But what if this was an odd value? So if let's say for some reason we are given x to the power 5, So in this case, we can also treat this as x multiplied by x to the power 4. So in this case, we would just first multiply it with the current value of x, and then we would have an even value of n, and then we would just simply return the same logic. So this is going to be x multiplied by x square and square of it. So yeah, that's the whole point. Now there is also one more last final edge case, and I know you all must be done with all the edge cases, but if the given value of n is equal to 0, then anything to the power 0 is always going to be 1. So this is the standard thing. So we can just directly create a case and return that if the given n is equal to 0, we can directly return value as 1. So let's do a quick recap. We are basically going to do x to the power of n as x square and n divided by 2. If the given value of n is odd, then we are going to do x multiplied by x square and n divided by 2. If the given value of n is negative, then we are going to first convert x is equal to 1 divided by x. That's it. So this is the whole solution. It works as expected. Time complexity, as mentioned, it's going to be big O of log n, which is exceptionally good. Space complexity, apart from storing a couple of variables, we are not storing much, so it's not going to be that expensive. And now let's see the coding solution. So the coding solution is going to be quite straightforward. First, we are going to handle the base case where if the given value is equal to 0, then anything to the power of 0 is going to be 1. So we can quickly return that. Now, if that is not the case, first thing we are going to do is to convert the given n, that is an int value, to the long value, and this is being done for some specific edge case scenarios, nothing more than that. Then we are going to check that if the given n is equal to negative, we will first have to convert n to positive, and we will also have to replace the value of x with 1 divided by x. So basically we are going to be treating n as positive every single time, no matter what the value has been given, but we will just update the value of the given x. Now we are going to create a variable called double result and current product, and this is to store the total results and the appropriate result that we need to return. Okay, now we are going to use our logarithmic function where for as long as n is greater than 0, we are going to check that what is going to be the modulo of n by 2. If the value is 1, which means the given n is an odd number, so we are just going to do result multiplied by current product once. So that way basically we are going to be taking care of treating n is equal to even numbers for the subsequent values. Then we are going to be multiplying the current product with the current product, so basically square the base and then divide the value of n by 2. So at every single step, we are making the value of n, turning it into half, and then doing the multiplication. So, and then in the end, we can simply return the result. So let's quickly try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code beats 100% of all the other solutions, and that is because we are solving this problem in big O of log n time, which is exceptional, and we are also beating a lot of other solution in terms of memory, and that's because we are just doing things efficiently. So once again, the coding solution is present in our GitHub repository. Feel free to go and check it out from there. Thank you.